we're starting to get a bit of a picture here. For instance, have a look at these numbers nestled over here, okay? 4, 5, and 10 are all unbounded. I predict that all the subsequent numbers after that will also be unbounded. Can you think of why though? What's going on? What does this see? What does it do? As you iterate, it takes you further in a certain direction. Okay, it either takes you further in the negative direction or further in the positive direction, right? Now, as you square, okay, let's think about z squared plus 10. Okay. Now we've already got z squared plus 1, right? Was this plus 1? I think this was plus 1. Yeah. Okay. So have a very quick look. It doesn't take very long to think about what the values will be. We start at 0, and then the next value is 0 squared plus 10, right? So then you iterate again. What do you get? 110, and then you'll get 12,200. 12,000.
Can we just say a million?
Now, look what's happening. Notice how this thing, it just blew up, right? It skyrocketed pretty fast. But this is going even faster, right? And you can see if I put in another number, a bigger number, right? It's just going to do it even faster than before. 121 plus 132, and then on and on and on. Okay. Now, what if it was a negative? What if it was negative?
So negative
minus
10.
1.
Negative 10 also, because it's going to get squared, isn't it? Right? That squaring thing means, have a look at all the ones that are bounded. Have a look at them with me. We've got 0, negative 1, negative a half, negative 2.
Oh, I've got another bounded. Negative.
I've got a tenth, negative 3 on 2. What's another one?
Negative a third.
Negative a third.
Negative a quarter as well.
Negative a third and negative a quarter. Both bounded.
And me.
So clearly, you have to be in a kind of neighborhood, right? Does that make sense? Ba-ba. Does that make sense? Now here's my question to you. We've said it's in a neighborhood, okay? Can we be a little more specific about like, where does the neighborhood stop and finish? We've already got, okay, what's the smallest number I've got that's in the neighborhood?
Negative 1. Negative 2.
Looks like negative 2 is the most negative one. What's the biggest number that I've got?
Negative fraction.
Do I have any positive one?
1 over 10.
1 over 10 is the most positive one, isn't it?
Yeah.
Right, because there's 0, which is not actually positive. There's nothing bigger than a tenth that is bounded. Can you find anything bigger than a tenth?
Oh, okay.
You already know, by the way,
Let's try 9.
once you get to a half, you're already unbounded. Shh, off you go.
Quarter is
Right?
as well.
A quarter. Can you go any further than a quarter?
Wait, is it bounded?
It's not bounded.
Yes.
It's unbounded.
Oh, it's unbounded?
Yeah.
So that means we haven't gotten very far.
Let's
It's
try
got to be somewhere between a tenth and a quarter.
Let's try 9.
Try a number.
Can it be? I haven't
Try
tried.
it. You tell me. I didn't have the calculator in my hand. You tell me. So I'm gonna ditch all these unbounded ones, okay? Because I'm not interested in them anymore.
Unbounded.
We've so far been trying out all of these values in here. Okay. The important thing you need to get is that all of these numbers, they're all real. They're all real. They're all. If I square any of these, I'll get a positive number. That's what makes a real number real. Okay. Now I'm going to go push on that a little further and say this axis in here, which you're used to calling the x-axis, right? I'm going to call it the real axis. RE for real. Okay? Now ordinarily in the Cartesian plane, this axis here is y, and it's just another real axis. Okay? And so in some ways, all you've got is position. It behaves in much the same way. Okay? But this time, I'm going to add on that this axis up here is the imaginary axis. We'll get onto these implications of that in a second. Okay? IM for imaginary. Okay, now where are these numbers? These numbers that I've got in here, okay? I think that the largest one that we got, which was just out, was a quarter, right?
It's 7 over 40.
Say it again.
7 over 40.
7 over 40 is bounded. Okay, so 7 over 40, right? So that's 10 over 40. So 7 over 40 is good. Wait, isn't 8 over 40? 8 over 40 is also good, right? Because that's a fifth, right? So if I have like, if I put 1 over here, okay, I think a quarter will be somewhere around here, okay? Right? Is that okay? Okay, now, what other numbers worked? What other numbers worked? Well, let's see. I could get all the way over to -2.
That is minus.
Yes.
I rounded it down.
I'm going to talk about this in a second. Okay. Now, what we're getting is a whole string of numbers in here. Okay. We haven't checked everything, but we're getting a bunch of numbers in there. Okay. Shh. Now, here's where it starts to get a bit more interesting. Okay. I'm not going to give you a whole rigorous explanation of what complex numbers are, but I'm just going to show you how the arithmetic works. Okay. Because that's actually very simple, and it's something which you would have met very early on when you were doing quadratics, right? Example. Okay. So just write this short example underneath, okay? If I gave you this, sorry, just let me think about the numbers.
No stress.
Tom, you just want to win that.
Okay. So have a look at this quadratic, right?
He's beating.
Now let's solve it. Can you factorize it?
Tom's beating.
Can anyone factorize it?
No, you can't.
You would have to look for a pair of numbers that added up to -1 and multiplied to 1. I'm struggling a little bit. So instead, when you can't factorize, what do you do?
Use the formula.
You've got a formula for this, right? So you say x equals, right? And then what happens? What ensues? It'd be minus b, which is 1, plus or minus the square root of b squared minus 4ac,
No solution.
right? Over
2A.
2a, which in this case would be 2. Okay. Now be careful. Be very, very careful.
3i.
Let me finish writing this out.
Plus minus 3i.
Okay. Now at this point, you are used to writing no solution. Okay. Actually, if you were careful, and depending on how carefully you were listening, you were taught to write
3i.
no real solution. And some of you probably thought, psh, what's that about? Like, what other kind of solution is there? And the answer is,
Dun dun dun.
there are imaginary solutions. So how am I going to write this? I'm just going to introduce this new kind of, I'll leave that there.
Root 1 is I.
I'm going to say let, okay, the square root of this negative number, I want to be able to work with them, okay? So I'm just going to say this. Let's just call it I. Okay, we'll just give it a name. Right? So therefore, how can I rewrite this? Think about your surd laws and how this works, right? This is x equals 1 plus or minus the square root of... Now, think about this, right? For instance, the square root of 6, right? When you've got regular surds like this, you can break them apart, can't you? Right? You can write this as 2 times 3, which actually is the square root of 2 times the square root of 3, right? So surds, multiplication of surds is okay. Addition of surds doesn't work like this, but multiplication does. So here, instead of writing the square root of -3, I'm going to write the square root of 3 times the square root of -1, which I'm just defining as I. Okay? So we don't have real solutions. I don't have solutions that are on this number line, but I have solutions that are elsewhere. Okay? So that's this idea that such numbers exist. Let's try this guy with some simple imaginary numbers. Okay, let's just start with the granddaddy of all of them. Let's start with I. Okay. So I'm going to go Fi of z. So this is going to be z squared plus I. Is that okay? All right, now hold on to your hats because this gets a little bit weird. Okay, where do we start? We always start at 0, right? So Fi of 0, okay? You're going to square 0 and then you're going to add I. So you get I. Okay. Try it again. I iterate, right? Fi of I. What do we do to this number? We square it. So when you square I, you get -1, right? -1. negative 1 plus I. Right? Whatever that is. Okay, just stay with me, okay? I'm really interested in what happens when it iterates and goes over and over and again. Okay? So, by the way, just a bit of trivia for you. This is an imaginary number, right? This is a real number. When you put them together, we call that complex. Okay? Just a bit of trivia for you. Alright, now let's try this. This gets tricky, right? Because I'm going to have, well, you'll see. I'm going to do f of I of minus 1 plus I. What happens to this thing? I square it. That's minus 1 plus I times minus 1 plus I, right? The reason why I'm writing this out longhand is because we are not used to squaring these things, okay? And then I add I. Do I not? Okay, now, what happens is, we can expand brackets. I can expand brackets, right? Okay, minus 1 times minus 1. 1. Minus 1 times I. Negative I. Minus
Oh
I.
wait, no, it's minus.
Okay, then what happens in here? I times negative 1. I times negative 1.
No, but then you cancel it out.
That's not multiplication.
No, you
That's
cancel
addition
it
and
out with the
subtraction.
one on the outside.
I haven't got to there yet. I'm on to here now. Okay, I just did these two. I'm going to do these two. I times I, that's... You okay with that?
Yes.
Plus I. Okay. What's going on? Okay, 1 and negative 1 cancel. This negative I and this I cancel. I just end up with I. But I know where I goes. I maps to minus 1 plus I. Right? So here's my sequence now. Here's my dynamic sequence with I as my C, as my constant. I started with 0, and then I got to I, then I went negative 1 plus I, then that took me back to I.
So it works with negative I.
Isn't that minus I?
Isn't it
Isn't
negative
it
I?
negative
Is it? Oh yeah, sorry. Yeah.
Negative I didn't.
Okay, so do we need to try this again then?
Yeah.
It's still gonna work though. It is still gonna work. We'll just go a few more steps.
So I did it with negative I.
Oh, you did it with negative I, did you? I don't. Well, okay. That's okay. I happen to know that there's some symmetry here, which I'm taking advantage of. It will work with both. Okay. Where am I up to? Okay, what's in here? Right. I'm gonna go fi of negative I. Yes. So what happens? I'm gonna square this. What happens when I square it?
You get I.
You get minus. Oh, you get 1.
Minus 1 squared is 1.
You get 1.
I'm gonna
So it's
Careful.
I.
It's like I.
minus I times minus I. That's squaring this, right?
It's I. What?
Oh no, it's minus.
Negatives cancel
Yeah,
to your
so-
positive,
I.
which gives me I squared, which is negative 1. Isn't it?
Oh.
Careful, careful. Okay, so then I've got negative 1 plus I. No, I went back there anyway. There you go. Okay.
Oh yeah. Boom, boom, bam.
Didn't I?
No, then you're supposed to do
So
negative 1 plus I.
Yes.
Yeah, and which
Alright,
is that?
Got it. That's my Z
I
squared.
thought they were doing that.
Yeah, that's okay. That's okay.
It's the same, so.
Alright. So there you go. So I've got 0, I, minus 1 plus I, negative 1 plus I, which is clearly going to go to negative I.